All right, mathletes, this is the second part of simple rules of differentiation. I kind of left you with a cliffhanger because I thought we would do this in class, but I want to have this video up just in case you didn't make it to class or something like that. So here we go. This is like the big part of calculus. We're trying to figure out the power rule. And the last piece of homework when we were talking about differentiating from first principles, you did effectively this. You said, here's this big ugly calculation. Let's find the derivative. And you said, okay, well, it's some curve. Let's pick an x, and let's make an offset h, and then let's see what happens to the slope, the rise over run. As h gets progressively smaller and smaller, it more and more exactly approximates the tangent line, right? And that's all this is y2 minus y1 over x2 minus x1, which is change in x anyway. Right, this is just slope. When you plug this all in and like expanded this, some of you are using like binomial expansion, you cleaned it all up, and you got this mess down here. You said, okay, let's think about when h approaches 0, what happens? Well, this would get very, very small, and this would be negligible. This would get very small and be negligible, and you're just left with this, and that's the slope of this. What a lot of work, right? But there's a connection between the two of these, and some of you have found that already. And if you haven't, you can look at this. Right? We started with that, and we said its derivative was 3x squared minus 6. Right? Think about how this and this are related, and think about how this and this are related. All right, here's the homework that you did last night, or this is the 2 and 3. I thought those were applicable. When you did all this work, differentiated from first principles, you got 2 as your answer. I might rewrite it like this. 2 times x to the 0, x to the 0 is 1, plus 0, right? 2 is this. And I might write in B, you got 2 from x squared minus 3x, you got 2x minus 3. I might write it like this. 2x to the first minus 3x to the 0. Right? 3x to the x to the 0 is just 1. So, and this, I might write like this. Right? Negative x squared plus 5x minus 3 turned into 2x. 2x to the first plus 5x to the 0. And so you could rewrite these like this if you like. And if you haven't, really pause me and look at how this and this are related. Right? How this and this are related. How this and this are related. Right? You'll see the pattern in a second and a half, and then start me up again. Okay, so for sure, you take, this was 2x to the first plus 1, and you multiply this exponent by this constant, you get 2, you keep that, and you drop this by 1 power. Ooh, so 2x to the 0. This, the slope of a horizontal line at 5, you can think about it like this, 1, 2, 3, 4, 5. What's the slope of a horizontal line at 5? It's 0, so that's where that 0 comes from. So plus the slope there, which is 0. So 2 times 1 is just 2. That's where that comes from. Cool. The same thing applies to all of these, right? This is 2 times 1. There's the 2. Decrease the exponent, 1, right? This was a 1, multiply by the 3. There's the 3. Now decrease the exponent, x to the 0. Don't write x to the 0. It's just a 1, so leave it like that. So all of these are the same. All right. As they get uglier like this, you get 3 times 1, which is that 3. Decrease the exponent, that 2. Here's 2 times 2. There's that 4. Decrease the exponent. There's 1. And the slope of a horizontal line at 3 is 0, so leave it alone. Cool? In other words, if you're trying to find the derivative of something, right, you can take that exponent, multiply it out in front, and then decrease the exponent by 1. If there's a chain of them with addition or subtraction, just follow the chain along, right? There's calculus. Whoa. Cool. All right, if you'd like, let's try one or two out. Here's a Fairly easy one. This would, you'd say, all right, well, this is 3 times 5, that gives you 15, and then decrease the exponent by 1. So there's, it's not even worth writing the second one. So there's 15 and x to the second. Multiply that in, so 12, keep the plus sign, there's the 12, and decrease by 1, so just x. Multiply 1 times 3, there's your 3, decrease the exponent by 1 is 3 times 1 is 1, and then the derivative of a horizontal line at 2 is just constant 0, right? Same thing here, we might need to rewrite this because this is pretty ugly. Turn this, leave the 7x, but turn this into 4 times x to the negative 1, right? And same thing here, call this x to the negative 3. And now we can play this same game. All right, this is just 7. I'm not even going to do that. This is just 7, right? 1 times 7, and then decrease the exponent by 1. The x goes away. This negative 1 times 4 changes the sign. That's why it becomes positive there. And then decrease the exponent. It goes from negative 1 to negative 2. Same thing here. This negative changes the sign. So negative 3 times 3 gives you negative 3. So it becomes negative 3 squared, sorry. So negative 9, and then decrease the exponent by 1. Cool. If you really want, change it back into fractions because that's good form. They started as fractions, so leave it as fractions. Neat. That's calculus. High five, and I'll see you in class. Bye.